I think the companies want to spend as much as possible on the efficiency. So which means they want to use as less resources as possible to generate same or improved user experience. So that's the motto of the AI efficiency. And as far as I know, like talking to industry leads, like other research folks, I think efficiency is not only playing a prominent role in major companies and data center based companies, but also like everywhere in the AI world and non-AI world, efficiency is playing one of the prominent roles right now.
All right, let's kick it off. Hi, everybody. I'm very excited to welcome you to this event at the Product Management Exercises Community Sessions, where Sudarshan is going to be talking to us about AI machine efficiency for product managers. Sudarshan has a lot of experience at Facebook, at Microsoft, a number of other companies, and he's here to share what he's learned throughout his career with us and through his personal learnings. Before I kick it off, I do want to remind everybody that we've got our 10th cohort for the AI Product Manager program coming up. It's taught by Corey and Kai, who are product leaders at Uber and Amazon. And the program is 5 weeks. It's live online, full of workshops. And we've had a lot of very successful graduates who've gone on to become AI product managers. So we'd love to have you join us. If you're in LinkedIn, the link is in the chat. And if you're in Zoom, I will put it in the chat very shortly. Without further ado, Sudarshan, we're very excited to hear what you've got to say, and I'll pass it on to you. Feel free to share your screen as well.
Well, thanks all for taking time to join this session. Thanks, Rita, for introducing me. These topics would be like mainly on AI efficiency for product managers. And here is my bio. As Ida mentioned, I'm an engineering and product manager from having like 9 years of experience. Currently, I'm working at Meta as a AI ML product lead, especially focusing on AI infrastructure and operations. And prior to that, I was working on infra, especially focusing on cache, load balancing, and networking at Meta. And before Meta, I was at Microsoft for many years. Started as a software engineer, then transition manager, then transition to product manager, like played different roles for close to 15 years, I guess. My main focus area when I was leaving the company was like for, working on Office 365 and Windows Cloud Data Management Platform. Uh, then before which I was like mainly focusing on enterprise commerce for Microsoft. And a small disclaimer here, I gather a lot of information, and most of this information is publicly available. And this, of course, do not reflect my views or policies from my current employer or past employer. Yeah. Let me go to the next slide. So here is the agenda. What is AI efficiency and why it is important? And what are the factors affecting this efficiency? And like few examples, like what are the factors and how could we mitigate those factors using some strategies? And then lastly, let's discuss about the trade-offs and the conclusion. And feel free to pause me or raise your hand if you have questions, or maybe you can ask your questions at the end of the call. Anything is fine. So just to make sure we are on the same page, I'm letting you know what this presentation does not cover, right? So in general, whenever we hear about AI and efficiency, we generally tend to like think, right? AI like enhances like like uncovering the patterns, like automating the operational tasks and like streamlining a lot of processes. But this presentation, we're not talking about like how AI is going to help with efficiency, like how AI is like boosting our productivity for product managers or like any other role, right? Then what are we focusing in this particular session? So we are focusing on AI efficiency. And just to make sure, like we all understand what is AI efficiency, right? Like efficiency is like across any of the software things. Like if you see like how can we like use resources like CPU or GPU or memory, the minimal number of resources to maximize the revenue or the cost. So here we're going to refer AI efficiency as like performing tasks with very minimal number of resources, especially focusing on hardware and memory, and of course the power part. I don't think we could like discuss on the power part, but let's see like if you have time, and how could we improve the user experience and reducing cost. And quickly going through one of the example, right? I think, oh, sorry. Okay. Uh, I think we would have already heard about the DeepSeek and other SOTA algorithms which are in market right now. I think just going back in the time, like couple months back when DeepSeek was released, I think it created a huge hype. And if you deep drill down few other details, like why it has got so much of hype, like when we already have ChatGPT and Llama and few other AI models, I think it's about the efficiency, right? I think they could perform the same set of task with very minimal set of machines, and in fact, like I could say, like second grade machines. So they could do the same thing with NVIDIA second grade machines. Uh, and because of which, what happens? Like if the user wants to use any of this LLM or like any of this AI functionality, I think they could spend less to get more. This is what we need end of the day, right? Like if we all are trying to focus on customer efficiency. How could we give a best product to any customer with as less expensive as possible? So that's one example, like what I've seen in few recent months, like how efficiency is getting more and more important, especially from the AI area. So that's a uber context, right? So why we want to deep dive into this. And this presentation, of course, as I mentioned, this will like focus into the relation between AI, hardware, efficiency, and some of the SOTA techniques. Let's see like if we can cover some SOTA techniques, especially to design the optimized performance. Okay, with that, let's see like what are the, let me minimize this presentation window. Give me a sec. Hey, Ida, I have minimized my presentation window, so I cannot see anyone hand raising or asking questions. Please let me know if you say anything.
Absolutely.
Okay, thank you. So let's start with this topic, right? So why is AI efficiency so important? Like we just discussed about the DeepSeek model, then like we are deep learning models, and then ChatGPT is working on a lot of latest models with highest number of parameters. Of course, a lot of other companies, there are a lot of startups. But why it is so important? So if you see after COVID, I think like post 2019, there is a huge supply chain management gap. So what I meant to say, like there is very scarcity of resources. Very big companies like Microsoft, Amazon, like who maintains like huge data centers, they often face these fulfillment issues. Like they promise something coming up in next 18 months or 24 months, but unfortunately they could or they could not do those releases because they might find the capacity. When I say capacity, the hardware, so the SKUs, right? Or they might not. So it's literally like a capacity ice age. And what would have happened? So the same thing as I mentioned, the global shortage of silicon, hardwares, and other issues. So during these days, I think the companies want to spend as much as possible on the efficiency. So which means they want to use as less resources as possible to generate same or improved user experience. So that's the motto of the AI efficiency. And as far as I know, like talking to industry leads and like other research folks, I think efficiency is not only playing a prominent role in major companies and data center based companies, but also like everywhere in the AI world and non-AI world, efficiency is playing one of the prominent roles right now. Let's like dig deep into these aspects, right? Like improving user experience. As I mentioned, uh like what if you get a same LLM with less cost? I think that's fantastic, right? You could like literally use it for anything. So that's improved user experience and lead to very smoother and satisfying customer interactions and reducing the cost. So I will not get into cost details, but like if you compare CPUs or GPUs or TPUs or ASICs, each has its own cost. Let's imagine I created a model, a company created a model which is running on a lot of TPUs and GPUs versus there is another model which is working on CPUs and combination of GPUs. So the you could see the CPUs are definitely less costlier than GPU and TPUs. So which means there is lower energy consumption and it reduces the cost basically. And it is useful for both businesses and the individuals because end of the day, everyone wants a cost savings, right? Scalability. I think scalability also plays a prominent role here, especially when we want to create very large and complex AI models. Again, this is not something which happens every day and happens at every company, but the major companies and industry leaders, I would take example of Microsoft and few other companies, they invest a lot on larger and more complex AI models. I definitely know, like in Microsoft Suite right now, you have Copilot. So I think you are using Copilot day in and day out. So just imagine how complex these models would be, right? So scalability is very important. And of course, the real-time applications, I think this is the world going forward. You would see a lot of IoT, autonomous vehicles, and instant translations. the language translations, the language translation models. I think here is where we need very low latency models, right? I don't think like when you drive an autonomous vehicle, you would expect anything like more than particular threshold of latency. It's very important that these applications will have low latency power consumption as much as possible. So these are some factors. I'm not saying these are the only four factors, but these are the very high level buckets. I think there are a lot of other things too. I have not laid out them here for the sake of this discussion. Let's go to the next slide. Okay, so last slide we discussed why it is important, right? Now, I think like what in general affects AI efficiency. In the last slide, we were talking about the model complexity. Then we like lightly touch based on CPU versus GPU. I think like here there is a structured way, right? Like if you see this four here, the algorithmic optimization. I think uh, we could use any algorithm to create a machine learning model. Now we need to create a right balance. What algorithm we would create, and what is the software, what is the hardware, what is the size of the model. I think that's going to be playing a very prominent role when a huge and complex models are created. Let's deep dive into algorithm optimization next few slides. Then model complexity, yes, I think it's super important that that the teams working on these models, especially, they need to focus on what are the complexity of the models and what are the resources they need to train and run this data. Just an example, right? Let's imagine if it is a very small model and accuracy is not important. Let's imagine, right? Like there would be some instances where there is a recommendation model. So accuracy is not super important right away. So you could use a low complex model and probably it could be trained on CPU and partial set of GPU resources. It's just an example, right? So model complexity plays a prominent role in selecting the hardware type. And the third one here is hardware architecture. So CPU, GPU, TPU, there are a lot of other things too. Let's discuss more in the hardware architecture section. But each type of software or the SKU plays a crucial role in the efficiency. I cannot just take a huge complex model and start executing it on CPUs. It might not work well. The reason being CPUs are not like on par compared with GPUs and TPUs, and GPUs, TPUs, which were basically built for gaming systems and graphical systems, they are the best suit for the complex models. So I think we need to take a right balance here for hardware architecture. Then the data storage and processing, this is going to be important again. Uh, so the last part is storage itself. I think any good model, when I do not say like a huge or complex or simple model, I think any good model, any efficient model, I think one primary constraint that drives these models is the storage. So there should be very efficient storage, and processing is very important for very, very fast and reliable AI performance, right? Just imagine you are driving a EV vehicle, autonomous vehicle, and there is a lot of IoT, there is a lot of transactions happening at a single point in time. I think the data storage and processing here plays a very prominent role. So in any model, any ML model, any AI related task, I think data storage is one of the prominent role. People generally tend to not discuss much on this because they assume, hey, we anyhow have big data, we have Spark, we have a lot of these systems, but I think they go hand in hand. The storage definitely plays a prominent role in the AI performance. So these are four important things. Again, I laid out here. There might be a lot of other things too. Feel free to explore. I'll jump into the next slide. Okay, so we just discussed about the factors affecting AI efficiency. Again, this might be overwhelming. Feel free to write your question somewhere or let Ida know if you want to get any clarification. So let's deep dive into some of these topics, right? So these are the factors now: algorithm optimization, which means best and sort of state-of-the-art algorithms, and model complexity, hardware, and data storage. I might go into some details of each of these factor. Again, I might not deep dive, especially focusing on the people here. I think we are not academics, so I'll just go at the very high level. But feel free to explore. I have added some links at the end of the presentation, and the presentation deck is with Ida, so you can like share, like take it further. Uh, okay. Okay, so let's start with the first one, right? Algorithm optimization. So as I mentioned in the earlier slide, so the state of the algorithms are most important when we create complex and huge models. The reason being, it defines like what is the hardware we are going to use, how do we process the storage layer, and what is the scalability factor too. I think like everything need to be considered. As I mentioned, it's like a golden triangle. We need to take a bet like what do we need? Like, do we need latency? Do we need cost? Do we need performance? So I think here is where it plays a prominent role, and it needs, of course, like best in class engineers to like create this type of algorithms. And how generally these algorithms work, right? So they are structured into this process. Like in general, like it starts with initialization, then go to evaluation, then go to iteration, then go to convergence. So every algorithm starts with an initial guess or set of values, and here is where the variables are involved. And once it is done, it computes the objective function, so based on the current variable settings. So this generally happens at the evaluation. So in the evaluation, you see the computation of objective functions, and in the iteration, it adjusts the variables. And here is where you will start using the mathematical techniques like gradients, heuristics, a lot of other things. I think we have one slide after this wherein we touch base a little bit on gradients and the heuristics, but here is where the actual math happens. And the convergence part, I think now that we like done a lot of steps here, this process continues until the algorithm meets the predefined criteria. Let's imagine you set up a threshold that you need, like this is the output. So it keeps on and like iterating and come to convergence. And once the criteria is reached, once the satisfactory function is achieved, it will stop here. And here is where the algorithm optimization is done. So this is a continuous process in any huge model. I'm not saying like this is the exact process any model should follow, but this is at the very high level, right? You do initialization, then evaluation, the iteration. This happens continuously. We use a lot of mathematical functions. It might change if I create the model versus like if someone else creates a model. I think this could change. Literally, I could use some different mathematical function in the iteration because my use case would be different versus the use case could be different for someone else, and their mathematical function would be different in iteration. So here is where the things getting changed. And at the very high level, hey, Sudarshan, what is algorithm optimization? So you could say these are very mathematical methods designed to best fit the possible solution, right? I have given the definition here, but this is how it works internally on base of these four steps. Let's see this slide, right? Okay, so what are the types of algorithm optimization? So in the last slide, we said, hey, it's all about the mathematical functions in the iterations, right? And you would see like how many types of mathematical methods we have: gradient based, gradient free, then heuristic and meta heuristic methods. Do I need to know everything? Maybe not. I think it all depends on the use cases, right? Let's imagine uh, your algorithm wants to utilize a Bayesian theorem. So you might end up using gradient-based algorithms, right? And if you have an NLP, you would end up using a different mathematical function here. And do we have to literally implement these algorithm optimizations? One good news is, I think the latest suites, which Microsoft, like other companies are releasing right now, they already have a lot of this integrated. I think like we can just pick and play with them as long as we know the basic definitions and the use cases and the right trade-off, right, on the cost, performance, and the hardware. Okay. Before I go to model complexity, I just want to let you know the use cases, right? Where exactly we might use this algorithm optimization, right? So I think like it could be used anywhere. Let's imagine basic machine learning models. Like if you use this Bayesian theorem or like a gradient free theorem, like methods in the training models. So where the optimization algorithms adjust the parameters, what it does is it minimizes the error functions and enhances the predictive accuracy. So what would happen? So when it minimizes error functions, you do not have to train the same model multiple times. So you are saving on resources and the cost and the timing. At the same time, it is enhancing the accuracy, and which is exactly what we need, right? Let's imagine the use case is like EV, as I mentioned, the autonomous vehicle. I think you should have uh, as accurate output as possible. So this is helping us to predict the right accuracy for the complex machine learning model. And even if you see like operations, right? Like if you have a research based operations, I think here you would see like how it would allocate the resources, schedule the task, manage the supply chains. Example, you have an enterprise commerce system. Even if you take example of Amazon, where you place an order, there is an order which goes into supply, then fulfillment. So this entire thing could be automated using AI. And here, if you use the right algorithm, right optimized algorithm, it could literally save like millions of dollars for the business and the user. So those are the few optimization algorithm use cases, right? Like where we use in machine learning or like operational research and in fact engineering design or probably in finance, right? Like stock markets and a lot of other things. I'll jump to the next slide here. Model complexity. Let me minimize this guy. Okay. So model complexity, we touch base this in the second or third slide. End of the day, I think this plays again a prominent role. We do not tend to often create very huge models. It depends on the use cases. Let's imagine there is a Pinterest or Reddit. So where we wanted to create very huge ranking models, right? I think like here it makes sense because you have a use case and there should be a ranking model. It could be very huge and it could be very complex. But we need to understand that the complex AI models, they need a lot of computation resources, which indirectly says like we need a lot of resources, which leads to higher cost and very slow processing times. When I say higher cost, now it would impact both business and the customer. When I say slower processing time, it will again impact the customer and the business because every customer would want high processing times. So now we need to take a balance effort here. How we need to invest in the hardware to make sure we are not compromising on the processing times. At the same time, we are not getting high on the cost of the resources. So simpler models, I think like on the other hand, probably they could be less accurate, but they can be more efficient because of the speed and the resource constraints are the priorities for that. And I do know like from research experts or like industry experts, there are times when they pick very big model. I think like they created this model. Eventually, they want to break this model. They break this model into multiple submodels. They call it as like foundation models. Then they call it as like in-depth models, sort of things. Or there are instances when like companies spend time on literally picking small models and consolidate those models. I think it all depends on what they want to achieve. Do they want to achieve the higher speeds? Do they want to achieve accuracy or do they want to achieve the efficiency itself? Like they want to save on the resources, save on the capacity, right? It could be again the use case dependent. And what could be like so, okay, before going to impacts of the complexity, right? I think like on the model complexity we are talking about here, it could be like literally the training time impact, the prediction speed impact, and the resources, of course, and the data requirements, and lot of accuracy and efficiency things, right? What are the impacts that could create because of this complexity? So I laid out three things here. Computational resources. Again, like you might want to invest like very high on the hardware. Instead of CPUs, get GPUs, which have like more processing power, but it is very costly, both for training and inference. And cost on the large scale applications, right? Like cost is not only the hardware cost, it's a people cost, it's a capex cost, opex cost, because everything need to be considered from the companies, because end of the day it is all paid by the finance of that company. And the speed, right? I think the deployment plays a major role in a competitive world, especially. I think when we create the complex models, it could be very slower to deploy because the scaling factor is very uh, complex. It's not that easy when you compare with machine learning models, which are like simple and small compared to the complex models. I'll jump to the next slide here. Okay, now that we discuss what is model complexity, what are the impacts of complexity, let's discuss some strategies here, right? Uh, these are some strategies. Again, like this is not one stop fit, but we could use it for different use cases. I have like added some links here so people can explore more after this call. So future engineering. So future engineering plays a major role. I would say like in my current research, I learned that future engineering is like almost 30 or 40 percentage of entire machine learning creation itself. So just imagine the size of future engineering teams, right? The reason being, uh, unless you pick like right futures, I think the machine learning model cannot be very efficient. So the teams need to make sure they need to ensure that features are well chosen and they need to reflect the underlying data. You could just take an example of a real estate. I think like that's basic algorithm which we read like whenever we start our machine learning, right? Like wherein you have a cost and square feet, then you need to determine like what would be like a cost for like 1,000 feet, 2,000 square feet. I think if you remember, like we used to label those, right? There could be like 100 columns. You will not play with 100 columns. You will play with like 3 to 4 columns. You will label them. You call them as features, and they will start like implementing them as inputs for the machine learning models. Similar thing, like unless you pick right features, right labels, I don't think the machine learning model could be effective. And that's on the future engineering. I think we can drill more into the future engineering, right? So why is it important? I think uh, the process, like what is like future versus future engineering? The future is, as I mentioned, the well-chosen underlying data. But what is future engineering? So it is a process of selecting and creating and transforming the raw data. In the last example, we said, hey, we have 100 columns with all the cost, bedroom size, and everything, right? So we use all this transformational data into a more useful format for machine learning models. We need to underline this most useful format. Here is where the future engineering team comes into play. They need lot of domain knowledge. Unless they have domain knowledge, it is very tough to understand the raw data and create a gist out of it. Okay, and the domain expertise is very much important, not only to extract and manipulate data, but improve the model performance and accuracy. And this is like a continuous process. It's not like a machine learning model is created, a feature is created, a feature engineering team creates the features, that's it. No, they constantly revisit these features. So this is what the feature engineering does. They constantly revisit the features. There are a lot of iterations, and every time they try to make the model as efficient as possible. And what is the process they do, right? Again, like because I want to use one example, I'm not deep diving into the other factors, strategies here. I'm just spending some time on future engineering because this is something which is super important when we focus on machine learning and AI sort of projects. So, so is the reason. And what is the process for the future engineering, right? So, because it is data and a person needs domain knowledge, and they will play with the raw data to create a future which would be like used for performance and accuracy. So it will have data exploration phase where like understand all the raw data. What is the data? What's the distributions? What's the relation between all this data, right? They need to make the data exploration. Then of course the data transformation. So converting this data into a format that is suitable for the machine learning things, right? That's very important. Then the future creation itself. So then they start creating the futures. Like out of those 100, 200, 300 columns, now they need to create new futures by combining from some columns or combining with the existing futures or like extracting some new sort of insights from the existing futures. And once it is done, not every feature would be selected for the final evaluation. Okay, let's imagine 100 columns, like 20 feature creations. Then they need to choose the most relevant features for that model because the same feature set can be used by any model. So is the reason they need to make sure that the feature selection is plays a prominent role for that particular model. And I think if I just take few examples, right? Let's imagine you ask some question to ChatGPT, hey, like what is machine learning model? I think this is where the text processing or the pre-processing will happen. So what it does, it will do the tokenization, it will do the stemming, and it would stop word removal for the text data. It does a lot of steps internally, and you could apply the same thing for time series features or discretization features. There are a lot of features. Again, we do not have to have knowledge on each and every feature. It's not needed, but based on the use case, you might end up like getting into those details. And now that you know how to play with these strategies, it shouldn't be a huge problem understanding those feature processing. So that's pretty much about the future engineering, right? And if I just touch base, let me quickly to check the time. Ida, how much more time we have?
You've
Do we
got
have 10 more
20,
minutes?
you've got 28 minutes. Yeah, you already have a question. Do you want to wait till the end or you want to take questions now?
Let's wait till the end because it's going on in a good flow. I'll just
Perfect.
end up in the next 6 or 7 minutes probably.
Perfect.
Okay. And few other things here, the simpler models, I think like not every time you will end up creating a huge NLP model. I think take a best bet if it is like if it is some model which could be done with linear regression or decision trees. I think there are a lot of academic research has been done, like what you could pick for a particular use case, what machine learning model you could pick. Then infrastructure optimization. Let's talk about the infrastructure and hardware in the next slide. Then deployment, of course, we discussed in the last things, and proving techniques. and a lot of other techniques here. And just to make sure we are on the same page, right? So what is pruning? I heard it for the first time. I think pruning is pretty famous in machine learning. It's like giving your machine learning model a much needed haircut, right? Like removing unnecessary branches, parameters, making it leaner, faster, and more accurate. So that's very high level definition of pruning here. Okay. Now let's go to the next slide. So this would be the last topic, hardware architecture. I think there is a storage layer too. Hardware, of course, it plays a prominent role, and especially the choice of the processors, right? CPU, GPU, TPU, ASICs. Again, we do not have to know everything, but these are some sort of processor types. And of course, memory and capacity. Each and every resource type plays a prominent role and influence how quickly AI model can be trained and deployed. I think you need to underline this, how quickly AI model can be trained and deployed. I think this is where the competition starts, right? Every company is investing on AI model. Whoever can invest time to make sure that quickly train the model and deploy the model are the market winners. Just letting you know. And choice of the hardware components is very important. I think it's possible to access AI model training by using the right hardware. So let's see some of the hardware which is pretty prominent right now for the AI models. So these are few well-known types of AI hardware, right? Sorry, I use a Google DeepMind picture in the background. I hope like you can still see the text here. So CPUs, GPUs, TPUs, NPUs, ASICs. So each plays some or other role. CPUs are pretty much popular, right? These are like general purpose processor, like we can use for AI task and non-AI task. We could use it for anything else. And GPUs are very specialized process and they are good at parallel processing. I think this is a reason generally companies tend to use a lot of GPUs because it could accelerate your AI tasks, especially for text processing, image processing, or even the video processing. And then we have TPUs. I think these are designed by Google. And now probably you would already know that each company like Microsoft or Google or Meta and even Apple, they are coming up with their own chips, like process, I would say. So they are proprietary and they like create those based on the customization they wanted. So you might not see this hardware externally, but like TPUs are like pretty common in Google processing, especially the Google DeepMind. What are the few examples, right? Who are the market leaders for CPU, GPU, TPU, and these things? And you know this, NVIDIA is a leading provider for GPUs for AI, especially with the recent models, right? A100 and H100. These are pretty famous models. These are super fast. I would definitely recollect that A100, I think it's 20 times faster than its predecessor. 20 times faster. Just imagine, instead of taking like 120 hours, it would like 100 hours, like it would take only 80 hours. So it's too fast, the A100. And then Google TPUs, we just discussed, it's very Google's DeepMind infrastructure. They especially use it for training and inference. I'm not talking about storage here because generally storage, like teams tend to use it like CPUs or the base GPUs. Then of course Intel, AMD, and a lot of other companies are investing a lot on CPUs and GPUs. What are the future trends? Like if you see like what is the next for AI hardware, right? So because we discuss strategies for algorithm optimization, then model design, I think if we can see this, like the example I mentioned, the NVIDIA's A100 Tensor Core GPU, it's 20 times faster than the V100, the past version. So they beat the records every time. I think this enhances machine learning and the deep learning training a lot. But the caveat here is whenever any company comes up with new SKU or hardware, right? It's not that you will get this hardware right away. The companies will place the orders, it will go into the fulfillment base, like a lot of other phases. They might end up getting a partial of these orders in 6 months, 12 months, 18 months, 24 months. So you could not expect, hey, A100 is great, Sudarshan, let my company like spend 100K on A100. Yes, they can do that financially, but there's no guarantee that they could get those queues on right time. So is the reason I think they need to make a right balance with existing V100, A100, H100 sort of SKUs. Then you could see this example in the second point, right? Uber improved ETA production by 5% and cut power consumption 50% using TPUs. Imagine the power of this hardware. So they replace CPUs with TPUs and literally they could like say predict the accuracy by 5%. So 5% is very huge and power consumption cut by 50%. So they might need only half of the resources they needed in the past, right? So that's pretty important. And if you see the stats here, the global AI hardware market is projected to grow 17.3 billion 2020, 234 billion 2027. This might not be super valid now. I used it like 6 months back, I guess. But just see the number. Between 2020 and 2027, the size is going to increase by almost uh, 10 times or 15 times, in fact. So that's the size of the market right now. And almost like 70% of the companies intend to boost their AI hardware investments. So which means they will spend as much as possible on GPUs, TPUs, and a lot of other things, like especially the cloud-based companies, right? Microsoft, Amazon, Oracle, they are expanding their AI hardware. They literally want to fill their data centers with as many GPUs, let's talk about GPUs, right? As possible, because they want to enhance their cloud-based solutions. And that's how the cloud-based companies survive, right? They want to give the best solutions for the customers and the businesses, so they could get more business. I would just spend like 30 seconds on this, especially in the interest of the time. I could see it's 9:39. Uh, Data storage and processing. This is one of the aspect, right? This was the fourth one, along with the optimization and design and hardware architecture. As I mentioned, most of the times people tend to not give much intense on this. The reason being, like it's like a default. People take it granted. Hey, anyhow, we have storage. We do this processing. It's nothing new. But I think the performance of the storage systems also plays a very crucial role for the AI workloads, especially for the workloads where it is data intensive and compute intensive. I think if you do not play if you do not focus on these aspects, it is going to impact the overall AI model in every aspect, right? The profitability or the productivity, it will impact those things. So it is very important to focus on data storage and processing. And for what type of workloads we generally do see for the model, like very complex models, right? Handling diverse data types, like the same example, the real estate example, wherein you have 100, 200 columns, then you end up creating futures and pick the best futures, do all the future engineering. Yes, end of the day, everything need to be stored, everything need to be processed, they explode, and the raw data need to be converted to machine learning understandable format. Here is where storage plays a major role, like handling all those diverse data types, the real-time processing, large data volumes, right? And making sure and ensuring there is data availability and reliability 24 by 7. That's pretty important. And what are the factors that affect the storage performance? At the very high level, throughput. Uh, Higher throughput improves the data transfer rates. That's pretty important. And latency, and then scalability, and then resiliency. If you see these two, right, latency and scalability, again play a prominent role, right? Lower latency enhances the system responsiveness, and especially the scalability part is also important, because the system need to adapt with the changing data needs. Of course, without performance bottlenecks. There is a machine learning model created, there's a future engineering, there is a storage. Eventually, there could be like after 6 months or 8 months, you would see so much of traffic on this model. I think it gets so important that the model, so the data storage part keeps on adapting to the changing data needs, right? There could be like 3 million users 6 months back versus 30 million users. Just multiply the amount of data, images, like videos, whatever it is. So it's a continuous process. There could be like a bigger teams in the big companies, especially for the data storage and processing. But it's very important if you see from data storage and retrieval and the reliability perspective. So what is the conclusion? So selecting the right storage solution is very vital for the optimizing AI workloads, especially on performance, scalability, and the cost. Trade-offs. Okay, well, we discussed a lot of factors. Okay, well, Sudarshan, which factor should I use? Again, as I mentioned, there is not one stop fit for every use case. Uh, Especially uh, like if you see this golden triangle, right, where you have cost, performance, and latency. This is like a golden triangle which we generally see in the big data Hadoop sort of thing, where we just want to compromise on something to achieve something else. Same is the case for machine learning model, right? I think if you want to like save on cost, I think it would impact latency and performance. If you want to increase the performance, you need to like high cost or like low latency or high latency. So we need to take a trade-off here. It all depends on the models, the use cases, right? Uh, Example, let's like few examples, right? Edge devices or like image recognition. If it is fraud detection, if you take fraud detection, okay, if you take this example, right? I think the speed of detecting the suspicious transaction is very important. We cannot take a trade on latency here. I think the performance plays a super prominent role because it's a financial transaction. It need to be happen in a real time. But let's take image recognition, right? Uh, see, you do not have the have the highest accuracy for image recognition, right? To more complex models, right? It could be fine. It could be like 90% accurate, 95% accurate, but it do not have to be 100% accurate because like world is not going to stop with that. But finance is like a different ballgame altogether. And autonomous vehicles, I think autonomous vehicles again, it should be like highly performant and with very minimal latency. That's very important for autonomous vehicles. And speech recognition, I think again you can take a call here. It could be like little accurate. I think we can compromise on the accuracy part here. Again, it all depends on the use cases. As I mentioned, we could take a call, and especially when we maintain the on-premise AI infrastructure, I think all these requests, right, all the inference requests, they generate some sort of revenue to the companies. I think they need to make a call like what's the revenue versus what is the investment they're doing. So it's very important for the companies and the customers and the businesses to make sure they play with this rightly and make the right trade-offs. Okay, here is a conclusion. We discussed about AI, factors impact the efficiency, and some of the strategies. I think this synergy between the AI, hardware, and efficiency is going to shape the future of engineering. The more and more companies are investing on AI, I think at one point in time, you might not see enough machines, enough people. So they need to start focusing on efficiency, which they already started from last couple of years. But again, I'm just emphasizing on this statement. Uh, this is pretty much what I have, I guess. I have added some references here if you want to just deep dive into those. And thank you, Slide. Hey, Ida, I cannot see the questions, but let me go to the speaker view.
I will help you. We've got one already. Thank you so much, Sudarshan, for such an insightful presentation. I think we all learned a lot. We have one question that I will share right now, but if you are in Zoom, please feel free to either post your questions in the chat or raise your hand. If you're watching from LinkedIn, feel free to put it in the chat and I will check those as well. The first question is there any way to estimate latency range after model training given fixed computational resources? We're facing a lot of issues such as training a model. Realizing the latency requirement makes it untenable, even a quantized one, and moving on to training a smaller model. This is throwing off timelines as well as blocking downstream backend developers.
Okay, I think it's an interesting question. I just want to know more about the use case because, like, as we discussed, right? I think every use case is different. Uh, do you want to add the use case here? Like, I don't
Uh,
know who asked this question.
Hey, Sudarshan. It's essentially a search-based use case where there are a lot of different models going around that are a part of the use case. But the biggest one is an embedding model for which we have trained multiple models, starting off with trying to use LoRa, to train the Llama version that was released last year, and dropping down to about a Stella model this year. Essentially, is there anything more specific you want to know?
No, I think thanks for clarifying on the use case, right? Let see again. My response might not be super accurate for your specific case because like each case is different. If I take my prior experience from Microsoft, like any other company, right? I think, uh, um, and just to make sure we're on the same page, we're talking about the latency here.
Yeah. We're mainly talking about latency.
Okay, so if I take the example I have from Microsoft, wherein we are working on a finance data, especially we wanted to forecast the sales for Microsoft sales data. So when we created this machine learning model and it underwent the training, like before it goes to inference, right? I think that for the latency part, like when you have the iterations, I don't know like how the iterations like work for each instance, but like we have cases where we have a internal model called as a MECAF deployment model. So what it does is it makes sure it iterates on this training model, with a predefined feature set and a parameter set, and it runs every particular time, right? I think that it depends on the machine learning model size. There are model sizes which runs for a week versus there are model sizes which run for like entire a quarter, like 3 months to 4 months to generate the number, to generate the data. So what we generally do is we do a lot of checkpointing and saving to make sure like if we want to like just make a change somewhere in the machine learning model, it will not literally start from the scratch, which would again take like 3 weeks or 3 months altogether, but it would start from that particular checkpoint and take the new code set changes that happened in the model and run from there.
Uh, so maybe here is where we may be going wrong. We are starting the model serving process post we have a model that is giving good enough quality. Are we doing something wrong? I mean, should we start off at the first iteration itself? I mean, first iteration of the model being sort of ready.
Hey, Ida, can you hear me?
Yes, Sudarshan, we can hear
I'm
you.
extremely sorry. I think my laptop got disconnected. I don't know the reasons. I connected from my mobile. Sorry.
That's okay. That's okay. Ashish, do you want to finish off your question?
Yeah. So Sudarshan, you were talking about iterations. Just to give you context, we had iterations about 3 weeks or so for each epoch, I would say. But we did not start the model serving process, which is making the model available or to see to design the solution of how it will work in a production environment uh, until the model was giving good enough quality. We had multiple iterations, and only after that did we start the design and process of model serving.
Right.
Did we do something wrong? Did we should we have started after the first iteration itself?
No, I think, see, just making sure, right? You could do both the ways. I think like whatever you did was right. So making sure you run multiple iterations for the training, and once you define, okay, it looks accurate and we can go further, you guys started working on the inference or the serving model, right? So
Yes,
uh, the only question to you is like, is the hardware consistent between both the training and serving? Because in general, like if you see, companies tend to use a lot of high quality soft like hardware, GPUs in the inference, and partial of like CPU plus GPU in the training. So here is where you might see accuracy issue or the latency issue. I think we are talking about the latency thing, right? That's one
yes,
point.
yes,
Or probably, so if you can like look into those, I think that's important. And second most important is, I think there are use cases where once few iterations are done, people tend to go into the inference. They create the inference, the iterations are done. Because let's imagine you spend like 15 iterations and then go to serving and something failed miserably and going back in the time, versus like playing with few iterations, going to serving. And whenever you have more iterations, right? Iteration 3, 4, 5, 6, 7, you don't have to push each and every iteration change to serving every time. You could literally group up these changes. Let's imagine, right? Just taking a number like from the thin air. So 1 to 3 iterations, then just imagine there's an inference model which got created and it is okay, it is fine, right? It's not super accurate. But then when we release the second version, I think between the iterations 3 to 6 or 3 to 9, we will buckle up all these changes together, making sure you have all the checkpoints and the save points and everything, and push those changes into the inference, the final model. So that's both the ways you can do. Like maybe like group the changes together and like push the changes individually from each iteration to the serving.
yeah. That is pretty much what we did. I just want to know. So you hit the nail on the head. Our main problem is development environment resources and production environment resources being different, partly because of
Hmm.
cost reasons. Where
Right.
okay, not getting into that. But my main question is, given that I have a list of production environment resources handy, is there a proper way to estimate before the model training itself uh, regarding how much latency range is this model going to take? For it,
It's a,
I am fine with the 10x sort of range as well.
it's a good question. I would definitely say there are tools. I might not able to explain the tool which I generally use, but there are tools which could forecast the accuracy and size of the inference model, and it needs the stats from the training, the logging of the training, And it also needs a hardware type, and we just discussed, right? The hardware type plays a prominent role in both training and serving, and look like you guys are using a different hardware for both the training and serving. It doesn't matter, but end of the day, the hardware type, the training model iterations and the parameters and all the other features, like what are the login things, if you could use this to predict the forecast for the serving using some sort of tooling. Each company has their own sort of tooling. This is called as ROI future, return on investment future, because not every training model would be into production for sure, right? So they define the ROI. If they think the ROI is good and it is going to help business or the company, then only they will go into the serving phase or the inference phase.
So that is definitely helpful. Once I know
Yeah.
that some tool like that exists, I will
Yeah, I think
search for it.
if I were you, I'll do a couple of things. So one, I think if you guys are like very having a hard stop on the resources or the hardware, just try to see, like, you can request of ChatGPT to like find some ROI sort of solution. Okay, that's one way to do that. If not, if you do not find a tool altogether which is like open source, you can still get the high level idea, like what exactly you guys have to do.
Yeah, we did that human level estimation, but we were 10x off, which is why
Very odd,
I'm
very off.
wondering. Yeah, yeah,
Yeah, 10x is very off, right? So
yeah,
it's very tough to let our VPs know, hey, we are 10 times off. Now we need to like spend something else. I think it's a bummer for them.
yeah.
Agreed.
Yeah.
Yeah,
Thanks a lot.
sure.
We've got one more question for you, Sudarshan. We've got, do we get to scale hardware and improve efficiency while using offset AIs like Azure AI?
I think I need some clarity on this question. So can you repeat the question?
Yeah, for sure. And Pavani, I know you've asked it if you wanted to also provide more information.
Sure. Hey, hi, Sudarshan. Thanks for the thorough session. Our company is moving towards AI, and we are planning to adopt Azure AIs for reporting and analytics. So, everything that is covered in this session looks like if a company wants to build something on-prem, then we get to scale the hardware to improve efficiency. But in case if we are adopting offset AIs such as Azure AI, so do we still have the chance to improve efficiency while you know scaling hardwares or like optimizing these algorithms and all? Is it something that we control when we are specially adopting something that is built by somebody else?
Okay, so it's like on-premise versus on-cloud, right?
Right.
Right. I think, see, it depends on the company size. If you take example of Microsoft, Amazon, they would treat themselves as on-premise companies, right? So for you, Microsoft is a cloud company, but for them, it's an on-premise company because they own the data centers and they could play with this hardware. They could literally play with GPUs and TPUs for their own Copilot. Versus, if someone uses example, I have a small company, I want to use Microsoft as a cloud and I want to implement their services. You still have an option to select between what type of hardware units, GPU versus CPU versus TPU. But your question is, hey Sudarshan, okay, well, I'm using the cloud solution. You could still pick the hardware type, but how do I implement efficiency there? Because you said like hardware plays a prominent role, right? I think this is very tricky for the reason being, you are picking this hardware from the data centers, which is on-cloud solution, and you cannot literally customize it. You have a customization till certain level, but not to the level which we need. So what I would do in this type of scenarios is, see, there are a lot of efficiency, right? We discuss about algorithm optimization, we discuss about model design, we discuss about the hardware architecture, data processing. If not hardware architecture, I think you could still focus on algorithmic optimization. What are the mathematical models you could use? What are the, like, do you want to use NLP model, regression model, or a different model? Do you want to use a complex AI model or a simple small models altogether to generate your solution? Do you want to use Big Data Spark for your data processing or something else? I think we can plug and play with these other three factors which are in your control versus hardware which is not in your control. Hardware, you could still do some part of it, but not everything.
Right. Okay.
Yeah.
Yeah.
And just to like add one more thing, right?
Mhm.
So there are companies right now who are working on heterogeneous hardware. So this is little new to the AI world. So what I meant to say, if your company want to be a mixed cloud, right? They want to get something from Azure, like Microsoft, and they want to spend something from their end. They could still do that. There is a mixed cloud concept wherein they could use some resources from Microsoft versus some resources internally from your company, and
Mm.
you could create an encapsulation for your AI developers to use any sort of hardware, but underlying you would plug and play with this hardware. You could still have AMD, NVIDIA, CPU, and GPU, but for a user who is building the model, it doesn't matter, because end of the day, he want to create a model, he will create a model. It doesn't matter what type of hardware he's using underlying. Again, it's a pretty new. It's still evolving, but that's one thing that's happening right now.
Right, that gave me some idea. Thank you, Sudarshan.
Sure.
Thank you so much, Sudarshan. It's been incredibly helpful. Thank you for
Okay,
everyone's
I have,
patience. We had a few issues come up.
sorry. If we
Yeah,
have like 1 or 2 minutes, I have a quick 2 questions.
Go
In
ahead.
case you don't mind, Sudarshan. Uh, so I just wanted to check if there is any stable sort of distributed GPU system that you can set up across different GPU models for suppose A100 and L4s. Because giving context, my currently for me developer costs are a bigger problem than hardware costs. Uh, for example, model parallelization we are able to do across same models of GPUs, but not different models. Have you ever done something like that, or there exists something like Spark for GPUs or something?
No, it's a good question. I think for the last question where I answered about the heterogeneous hardware, right? I think companies are spending on heterogeneous hardware. I would definitely say it's a possible solution, and companies are already doing it. I will not go into the deep details about this because it's
Yeah, I
still
will.
at the
That's
very early phases. But just imagine, right? At the beginning of the presentation, we said, "Hey, we have scarcity of hardware after COVID. Like we have this capacity usage issues." Which means like after 1 or 2 months you might end up finding a lot of V100 H100 machines but not E100 machines. It's not that you literally throw all your existing machines and transition to new set of machines, right? You still need to make sure you continue with your existing hardware and add the new hardware, but at your software still works on that hardware. So here is where I was mentioning in the last question, right? This heterogeneous hardware plays a prominent role, but the problem is the compilation, right? So the compilation part would be different in AMD versus NVIDIA. Even in between NVIDIA chips, there would be a compilation difference. So people like teams are building an encapsulation. So this encapsulation should help address these issues. Literally making sure any code, like any machine learning model you execute, right? The underlying software will make sure it compiles in a way that hardware understands and gives back a solution. So this is evolving. Few companies are spending on it. I would say like only big companies are spending on it, but I hope there would be some tool coming up in the future which would help address these heterogeneous hardware issues.
Just one last question. You talked regarding data storage and processing in your presentation. Uh, just to check, currently we're using Spark 3 clusters for our data processing, both pre and post the model fine tuning. Were you talking about something different or something using something faster,
No, I think
specific to AI models?
no, I think that's a good question. I'm referring to the same thing. I'm referring to the same thing. Uh, there are much faster solutions to people tend to go into other solutions like Databricks. I hope you heard about this,
Yeah,
right?
yeah.
That they have a lot of advanced AI workloads which they're specifically focusing on AI, but it all depends on whether we want to build versus buy. If it is buy, I would definitely like ask people to go and explore these options. Again, I'm not advertising those companies, but that's the best bet. But if you're building internally, I think like the Spark clusters which you are using right now in a company, mid or like small size company or even the bigger companies, I think that should be fine. The only thing is making sure that the efficiency part is already involved into those, especially when we do that data exploration or like converting the raw data into features. So this should be considered. I think once this is considered, I think any engine in the
Currently, it
background
is
should
not
be
a
good.
bottleneck for us. Currently, it's not a bottleneck for us. I just wanted to check.
Oh yeah, 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 yeah. That's the thing, right? Buy versus build.
Yeah, Sudarshan.
Yep. Thank you.
thank you so much, Sudarshan. Thank you for taking all the questions. And I'm sure everybody learned a lot from the questions as well. Thank you so much for the presentation. Like I said, thank you for bearing with us for the technical issues that we came across today. It's never a dull moment, but nevertheless, hopefully everybody got a lot out of this presentation. I know I did. Thank you so much for the time and effort you put into it, Sudarshan. I think people can find you on LinkedIn if they'd like. And again, thank you so much. Again, everybody, if you want to become an AI product manager, join us on the week of May 12th, and the links are in LinkedIn and Zoom. Thank you so much. Enjoy your weekends when it comes, and enjoy your Friday as well. Thank you so much. Take care. Bye, everyone.
Thanks, Ida, for organizing. Bye.
Absolutely. Bye.
So hi there, my name is Kevin. I'm a product manager at a company called Vicasa. Really, I've had some exposure to AI and ML products in my professional life, and really I joined the AI ML cohort to get a better understanding of like the end-to-end AI ML product development cycle. So yeah, I really appreciate the cohort. It's helped me a lot in product decision making, and yeah, much appreciated.